Nano fam, welcome back. Welcome back. It's been a long time. It's been a long time, but finally I found the motivation and the time to start to stream again. Hello everyone. Hello Johnny. Hello Undefnal. Hello 1401. Oh, it's so nice to see you guys again. Hotel lobby music, yeah. elevator music. LF, good evening. So let's put you all on the spinner wheel. It's time for the spinner wheel again. So we have Johnny, we have Undefnal. How are you guys? It's been months since the last stream, I think. Undefnal 1401. F. And if now, hey, if came to rig the game, so you came to rig the game. Let's see how that works. Hello, Vitali. I think you are not in the address book. If you want to take part in the giveaway, just post your Nano address. Illybob is here. Hello. Yeah, it's been a long time. But now, finally, I'm streaming again. And with a new spit change setup, as I already spoke about in the dev meeting today, my computer broke, my hard drive broke, and I bought a new computer and I brought the broken one home. And now I'm using the broken one as a streaming PC because Windows is still running. And it's more powerful than my streaming laptop, and I'm happy with the new setup. And I'm streaming with the wrong link, I think, because I still have to adjust some settings here. But that's okay. Okay, so we have 1, 2, 3, 4, 5, 6 people on the spinner wheel already. So if you want to take part, just post your Nano address in chat. And let me just see, do I have Italy? Do I have you in the address book? I don't think so. No, I don't. So just post your Nano address and then you can win 1 Nano every 10 minutes. So I'm removing you right now till I have the Nano address. And let's start the timer. Is it running? Yeah, okay. Yeah, so I bought a new PC. And it's so fast, guys. It's incredibly fast. It's so much fun now to work with or to recompile the code base, and if I don't have to wait for ages. And that really makes me more productive. And yeah, so let's maybe, I don't know what was the topic of the last stream, but a lot of things happened. I ported a lot of code, and I also merged a lot of upstream commits, and the merging took I think the most of my time. And although a lot of new code came in, the project still made a good progress. So let's see how the percent Rust script, what the percent Rust script says here. It says we are at almost 44%. So that's a good increase. And a lot of new code came in from the C++ side, and still we made progress. LF, how have you been? Yeah, I'm good. Illybob, hello. Vitaly says, what's the plan for tonight's stream? Good question. I don't have a plan for tonight's stream. I thought I would just start streaming again without a plan, and then let's see where we end up. I think I just want to continue the stuff that I'm currently doing. And the plan for the next streams is to focus on cleaning up the code, because we ported a lot, and I think cleaning up code is a very interesting topic. And that's what I want to focus on the next streams. And if Mel says the plan, listen to elevator music and drink from Nanomark. Yeah, that's the plan. 1401 says only 10 more minutes for the Bitcoin network to turn another 1.9 gigawatt hours into heat. Yay. Yeah, 10 minutes for just a single block and a lot of energy and lots of fees. Have you guys seen the fees lately? $200 fees for $300. It was insane. And if Bitcoin has high fees, that's good for us, really, because then maybe people will wake up and look for alternatives. Okay, so I think I just want to finish up what I was working on currently. I actually started to code a bit before the stream started, and now I have couple of changes that I have to commit, and I think I'm just going to continue from there. And now says we have seen them didn't pay a cent, lol. Yeah, $200 for a transaction. I mean, that's just ridiculous. Okay, so what I did is let's start with the node HPP, and let's have a look at the current status of all the things we have ported already. And as you can see here, I made these are the dependencies of the node class. So the node is the top level class, which just represents the whole Nano node, and it has many dependencies, and I marked all dependencies that I've ported already, and as you can see, there's not much left now to port. Basically, so here, the only things missing are Bootstrap initiator, Bootstrap server. So the bootstrapping part is not done yet, and now all of the vote processing code is in Rust. The confirming set this is new stuff from Colin that I merged already, and it's also in Rust already. Wallets, that was a huge thing to port. It's also in Rust now. And active transactions, that took me a lot of time. A huge class, ported it, and it's all in Rust now. Vote processor is in Rust now. The rep crawler is in Rust now. So yeah, we are getting there, Nano fam. We are getting there. So scheduler is not completed yet, and maybe I'm going to work on this today. LFLF, 100% Rust incoming. Yeah, that's the goal, 100% Rust. So just a couple of things missing. The scheduler I have to port, request aggregator, the ascending bootstrap service, and the bootstrap clients, I think, and then we're done. Not completely done. Then we're done with the dependencies of the node. Then we can port the node class, and then we can port the RPC stuff and the WebSocket stuff. But yeah, I'm really excited. So we are getting closer and closer to a full Rust node. And what I just did before the stream started, I ported unit tests. Unit test for the buckets, because I noticed that the bucket class was only being used in the unit tests on the C++ side. And so I thought, let's just bring the tests to Rust, and then I can delete the C++ class, because no one uses it then. And I've just finished bringing the tests to Rust, and now let's check if I can delete the buckets class. So this is the buckets class, and let's search for all references. And yeah, only buckets CPP and buckets HPP. So that means no one is using them anymore. So let's delete that. Which folder is it? Scheduler, not scheduler. So let's go to node scheduler. And let's remove buckets cpp and buckets hpp. And let's also update the CMake files. Node CMake. And scheduler buckets. And they are gone. Yeah, let's build this and let's commit this. And this is now not my super fast new computer. This is my old laptop still. So we have to wait a bit. Oh, okay. So buckets HPP. Oh yeah, the includes. We have to fix the includes. It's HPP. Oh, just here. No more includes. Let's build and let's commit this. And then we can focus on the hinted scheduler or the optimistic scheduler. So yeah, we have April now, and it's really looking good to have a full Rust node this year. Let's run the tests. Oh, and I also spent some time improving the stability of the tests, because there were some tests that always failed, and I found out why. And I fixed them, and now they pass. Not all of the time, but mostly. And while those tests run, we can prepare the commit already, because I think they should pass. So we remove C++ buckets. So see, tests still running, no failures. Oh, and the next Bitcoin block in 10 seconds. Sammy D, you're just in time for the spinner wheel. So, time for the first giveaway. Are you ready? Let's go. 1 Nano goes fearlessly to LFLF. Right? Yeah, LFLF. Congratulations. I hope your addresses haven't changed, because they are still the old addresses from the last stream. If your addresses have changed, please tell me. Oh, Sammy D said, I have a new account. Oh, yeah, that's good. So let's just send the 1 Nano to LFLF. Confirm and send. And then let's update. Let's update the address for Sammy. Oh no, I can't update addresses, right? I have to delete and create a new entry. Yeah, let's do that. Sammy. And this is, oh, how can I copy? How can I copy this over? I have 2 computers now. I have the chat on the other computer. How can I copy over your address? Let's go to YouTube, to my own stream. Maybe I can copy it from the chat there. I should have thought about that. Or did you send it on Twitch? No, YouTube. Sammy has a new account. Top chat. Live chat. Here. Okay, that worked. Save. Andifnal says, said it, rigged. Yeah, congrats from Andifnal. Thanks from LFLF. Congrats LFLF. So Sammy D. Inception. Okay. Let's close my own stream. Or maybe we just watch this live coding nano stream here. Inception. Okay. One test failure. Yeah, sometimes. Yeah, this is a test that sometimes fails. I haven't investigated why. But let's push this. Okay. Okay, so now the buckets. Oh, that means we can also delete the buckets FFI functions. I wrote a script. Find unused FFI functions. That finds FFI functions that are unused. And yeah, let's run this. And I love deleting code. Yeah, as you can see, there are unused functions that we can delete. A lot of unused functions. Let's delete all of them. So we have active transactions. Oh yeah, remember to restart the timer, 70. Thanks. Okay. Active transactions. Let's delete all of that unused stuff. Block cemented callback. So this one we can delete. This one we can delete notify all. We can delete request loop. Then we can delete the prior and where are they? Here we are. Buckets RS. I think we can just delete the whole file. Yeah, let's delete the whole file. Rust, FFI, source. Where was it? Consensus? Consensus. Buckets. And let's also remove it from the mod. From the module. Buckets. Okay. And let's also delete this tally stuff. Tally blocks create. Tally blocks create. We don't need tally blocks create. Destroy len. No tally blocks create and insert len. Yeah. No tally len. No tally blocks create and insert. Create. Insert. What else? Tally destroy, tally get, tally len. Yeah, tally get. Tally len. LFLF says, good that you reminded him, Sammy. Yeah, I have to get used to this again. Yeah, let's just run this script again. RsNano tally destroy. This tally handle, is this still in use? No. Nope, we can delete the tally handle. Yeah, we can. Okay. Vote with wait info vec add. Vote with wait info vec. Add. So this is not being used anymore. And the create is not used. Okay. Let's also commit this one. What does tally do? What function has it? LFLF asks this question. So the tally is the votes, all of the sum of the vote weight for each block. So the nodes, they vote on for each block, and the sum of the vote weight is the tally, or I'm not sure what tally. What is the translation of tally? What is the meaning of tally? Ah, okay. So this means, yeah. So it's a log of all the votes for a block with the vote weight. And yeah, so this should still build. And while this builds, let's also prepare the commit already. Oh. And we say remove unused code, FFI code. Remove unused FFI code. Makes sense, says LFLS. Wenderson, Nano's Delight. Welcome back, Wenderson. Let me put you on the spinner wheel. Wenderson. Alright. Okay, so while this is building, I think deleting all of that Rust code brings our ported percentage back down. That's okay. Let's check that. I mean, this number doesn't say anything really. It's way too low because it's taking into account all of the C++ glue code, and I think we are way above 50%. Okay. Still building. So now we could start with porting the remaining schedulers. Let's go to the schedulers. The election schedulers. So what they do is they decide which elections should go into the active election container. And we have the priority scheduler, and I ported this today. So the priority scheduler is this bucket system that Nano has with, you know, those 62 buckets, and they are sorted by recently used and account balance and so on. And this is the priority scheduler who does this, and this priority scheduler uses the buckets class, and I ported that today. So priority scheduler is done. So now we just have the optimistic scheduler, the manual scheduler, and the hinted scheduler remaining. Wenderson says, it's a pleasure. Watch the live. Yeah, thanks, man. And if not, I still don't know how the bucket work. So yeah, it's just we sort. It's not that hard. We sort all of the transactions into those buckets based on the account balance. And inside the bucket they are sorted after recently used. So the accounts that weren't used recently, they get priority. And it's a pretty cool system because it's simple and it works well. Sammy D says, I missed these streams. Oh, thanks, man. I love the vibe and the tech insights. Yeah, I promise I will make, stream more regularly again, okay? Okay, so, and what the other election schedulers do, I'm also not so sure because I'm also still learning about all of that while I port the code. So let's start with, let's see, we could start with hinted scheduler. How big is it? Yeah, not, okay. Yeah, not that big. Manual scheduler. That's really small. Oh, that's so small. I think let's just start with the manual scheduler. What does it have? Start, stop, push. Manually start an election for the block. So maybe, who calls this manual scheduler? Maybe the RPC? Tests. Tests and node CPP in start election. So maybe the manual scheduler is just for tests. Oh, giveaway time. No JSON handler here. Block confirm. Okay, so when we make an RPC call, block confirm, it calls the manual scheduler. So let's port the manual scheduler because it's such a small class. It shouldn't be too hard. It has this queue and it's public. But no one uses it, so this can be private, really. Oh, the giveaway. Sorry, guys, the giveaway. Let's. Do I have you all on there, Wenderson? Yeah. Okay, let's go. One nano, instantly and without $200 fees to Johnny. Congratulations, Johnny. Johnny, 1 nano. And confirm. And restarting. Now I remember. Restart the timer. Congrats, Johnny. So, what else? It has a mutex. What does it use from the node? Just stats and active transactions. So nothing special here. This will be easy. Okay, so let's start by creating a new file in the Rust folder. In the same folder then as the priority scheduler. Priority scheduler. Here it is. Ooh. And let's create a new one and call this manual scheduler. LFLF, no X and over under. If you had something wrong. Yeah, but we still have some time. Pies, are you? Oh, Pies is here. Hey, let's put you on the wheel too. Yeah, so manual scheduler. And let's create the file. So this is the file for the manual scheduler. So let's say pubstruct. Oh, you can't see. Okay, sorry. You can't read that, right? Why can't I? What's going on? Johnny says, wow, there was the stream was lagging, so I received the Nano before I heard R1. Yeah, the stream is lagging a couple of seconds. Manuals. Scheduler. Why can't I? No, okay, let's make it like that. Oh, okay, it is. Yeah, impl manual scheduler, and let's give it a new function. And let's just start with let's just go through the impl code here. And yeah, so it needs a thread. And I'm just using the same pattern that I used in the other code, which is not how you should write Rust code, but I'm just I'm just going to keep it very close to the C++ implementation until I have ported everything, and then I want to clean it up and make it Rust idiomatic. So I'm just gonna repeat the same code here that I used elsewhere, which is like that. So we need a thread join handle because the manual scheduler will run its own thread. So we say thread is a mutex. So I have to put it in behind a mutex because we just can't guarantee anything for the C++ code, and so I just have to be overly how to say protective here. So it will be a mutex option join handle. For the thread. And when we create a manual scheduler, we say this thread handle is none. Mutex none. And then we can bring these two lines to Rust. So they are just asserting in the drop. So in Rust, the destructor is the drop. So we say impl drop for manual scheduler. And we just copy the comment to the Rust side. And here we just have to debug assert that the thread was joined, which means the scheduler was stopped with the stop function. So we say debug assert self thread lock unwrap is none. So we're asserting that we don't have a thread handle, a join handle, and that means the thread was joined. Okay, so the next one is the start function, and now this gets a bit tricky. So in order to port the start function, I have to introduce a trait. Manual scheduler ext, and this trait defines the start function, and then I impl this trait for arc manual scheduler. So this is all not idiomatic Rust, but when I just write it like this, I can keep the code very close to the C++ version. And the reason why I do this is I have to move the ownership, or I have to create a new thread here and move the ownership of the scheduler into the thread, and at the same time I have to keep the ownership of the scheduler elsewhere. So that's why I'm putting it behind an arc, atomic reference count, a shared pointer in C++. And yeah, it's ugly, but it does its job. So in start, we are just copying over the C++ code here, so we have to debug assert. Now let's copy the debug assert from here. We are just debug asserting that the thread join handle is none, which so we are asserting that it is not started already. And then we say self thread log unwrap is some, and now we start the thread with the thread builder new, and we give it a name. And the name, let's check the C++ thread name here. Scheduler manual is scat manual. Oh, you can't see it. My picture, my video is in the way. Jabba or Jubu, hey, welcome. Your name sounds familiar. I think you are in the address book already, right? Let's check that. Yeah, is it the same address still? No, it has changed. So let's add you again. Add new entry. Same problem. Same problem. I have to copy it from my own stream chat. Oh no, maybe I can go to chat.restream.io. Does that work? Yeah, I'm now connected, but I don't see the old chat messages. That's a shame. Okay, then for this time we just go to my YouTube channel again. Chat. Okay, this is FM. Save. Okay. Prime Cobalt video. I love watching Prime. Primechen. Do you guys watch him too? So scat manual is the thread name. And yeah, now we just have to call spawn. Okay, giveaway time. And in spawn, let's just finish this. We have to say box new, and here we're going to put all of the code of the thread. And is this too early? Unwrap has to be put here. Yeah. So here is the thread spawn. So here we are going to put the code, and the code is just calling the run function as in the C++ code. So, and sorry, there's still something missing. We need a copy of the arc, a clone of the arc that we can move into the thread, so that we can say in the thread, we can say self l run, and that is the start function. Of course, the run function doesn't exist, but we are going to create that soon. And now let's just run the spinner wheel. Illy Bob, congratulations. Send to Illy Bob. RsNano. Let's restart. Congrats, Illy. Yeah, congrats. Yeah, so the run function. Maybe let's switch the windows. Oh. Let's move the C++ window to the right. And let's keep the Rust code on the left, because then you guys can see it better. Because then the chat and my webcam isn't in the way. So run. The run function is still missing. And I'm just going to port this from the top down. So I don't care that the run function, we don't have it yet. Let's just go keep the order as same as the C++ code, and let's just make the next port the next function, which is notify. So pub then notify, and it will just call condition notify all. So we don't have condition yet. Let's create that. Condition is a cont var. So if you don't know what a cont var is, cont var can be used to signal from one thread to the other that something is that something happened, something is ready, for example. So condition is cont var. Now we have to import cont var, and then we can call self condition notify all. So this sends a notification to all the waiting threads, waiting for this cont var. The next function is push. So let's add that. Push. What does it take? It takes a block. A block and a previous balance. So block, it's an arc block, enum. The previous balance is option mount and election behavior. Election behavior. Does it return anything? No, just void. Okay, we have to import block enum, import amount, import election behavior. And okay, so the C++ code, it locks the mutex and then it pushes the stuff into the queue. And we don't have the queue yet, so let's start there. Let's add the queue. And the queue is protected by the mutex. So we need a mutex. And the mutex contains the protected data. And will it just be the queue, or is there more? Oh, there's also a stopped bool, so I think there will be more. So let's create a struct that is protected, and I'm just going to call it manual scheduler impl for the lack of a better name. Manual scheduler impl, and it will have the queue, and the queue is a double-ended queue, so that is in Rust it's a vecdeck. And it with an arc block, an option mount, and what was the last one? Election behavior. Yeah, election behavior. No, not block. It's still called block enum. I want to rename it to block in this future. Okay. So push, back to our push function. So we have to lock the mutex. And And then we can push into the queue. We can push, block, previous balance, and election behavior. And now, and then we have to call notify. Okay, that's the push function. And the next function is predicate. Okay, let's port that one. Predicate. And it returns a bool. Ah, okay, so this accesses the queue, so let's move it to our impl struct. And this will return not queue empty. Okay. And now we have the run function. And this is the last big function. And then we're done. So run. Run. I don't make this public because this run function will not be called from the outside. And okay, so I'm just going to copy that code now into the Rust code and comment it out, because then I can just port it line by line. So first we have to acquire a log. Mutex log. Run also accesses queue. Should it also be part of the impl struct? Hey, yeah, LFLF is following closely. You're right, but it just it manages the mutex logs by itself. So here it is acquiring the mutex log, and that's why it can't be inside of the impl struct, because the impl struct is inside the mutex. So while not stopped, so stopped, we have to add the stopped field into our impl struct. This will just be a bool flag. Stopped, so bool. And so while not stopped, let's uncomment the braces. Next line is condition wait. This will be self.condition wait while, and fix our guard and the condition. And this is something where bugs can creep in, because in Rust it is the other way around. So in Rust we have a wait while, so the condition returns true if we have to wait more, and in the C++ code it's the other way around. In the C++ code the condition returns when we have to stop with the waiting. So here we have to say not stopped, so we have to invert the condition, and not predicate. So we have, what this line says is we are just going to stop here and wait until, or we will wait as long as stopped is false, so that means our scheduler has not been stopped, and we are going to wait until the predicate is true. And then only then the code will continue. The 10 minutes are flying by. Flying by so fast. Okay, let's spin the wheel. LF, it's you. Congratulations, LFLF. There you go, RsNano. Instantly, fearlessly, eco-friendly. LFLF says, isn't not predicate now not is empty? Maybe you could simplify this. So the predicate is, yeah, I'm gonna leave it like that because the predicate, it says when can we continue, and we can continue if the queue is not empty. So if there's something in the queue, then we can continue. So yeah, it is a not here. Is it? You're right. Let's. Yeah, okay. We use it more. We use it down there. You know what, LFLF? Let's inline this, but let's just port it first, and then let's simplify it a little bit, and let's inline it. Thanks for the nano, says LFLF. Okay. So this is ported now. And now we have a debug assert here. What does the debug... Oh, and I'm not going to port this. Introduce some random delay in debug builds. I don't want the debug builds to be different from the release builds. I'm not going to add that line here. So, next line is if not stopped. So the stopped is in the guard. So if not guard.stopped. We're going in here, and then we are increasing stats. So self.stats inc. Oh, I don't think we have a stats field yet. Action scheduler. Action scheduler, detail type, it's loop. Yeah, oh, self. We don't have stats. No, so let's add that. Let's add stats. Arc stats. Let's add that to the constructor. Oh, and we have more stuff missing here. The mutex is missing. Q. And stop is false. Okay. Oh yeah, so, and the wait while, it returns the mutex guard again, so we have to reassign the guard. We have to say guard is wait while. Okay, so now it looks better. So what does the code do here now? It checks if predicate else this. LFLF, do you still use the concepts of nullables? Yeah, I do. Or will you add it later to the manual scheduler? I will. So right now I'm not working test driven, and it's a shame because this is just the way that I prefer to work. But Nano has tests. Not real unit tests, but many system level tests or integration tests. And they are enough for me to port the code. But once everything is ported, I'm going to change the way Nano is tested, or RsNano is tested. And I'm going to use the nullable patterns, yeah. And I'm still using the nullable patterns in my other projects. So yeah, I can still recommend this to to everyone who wants to work test-driven. Did you try it, LFLF? So for queue front. So what are we? Pop front. So we are popping front from the queue. So let's say if let sum block previous balance selection behavior is guard queue up front. And now the lock is released, so drop guard. Yeah. You know what? This is now getting super ugly. I don't need a iflet because the predicate checks already that the queue isn't empty. So let's make it really ugly, but bring it to Rust, and then we focus on cleaning it up a bit. So I'm just going to add an unwrap here. And there should not be unwraps in the production code, or not many. But I'm going to keep it like that. And refactor it later. Later in this stream, I hope. Yeah, so LFLF, have you tried the nullable patterns? Oh, there's the chat. I'm in charge of setting up a testing framework at work now, but I find it rather hard to use nullables there. We need databases, and Java Spring gets in the way too. Yeah, it's not easy. It is not easy. But have you seen the YouTube videos of Chittertat? Chittertat is the name, and he wrote something with Java Spring and stuff, nullables with Java, and they wrote a nullable version of the database. What does Java Spring's use for database as a database framework? ORM tool. And I think they wrote a nullable tests for that. So maybe that could be helpful. But yeah, it is difficult. But once you get it working, it makes life really easy. Daily Beltos, hello, what are you doing? Oh yeah, so I just started coding. Yeah, I did not even give an introduction. Yeah, I'm working on Nano, RsNano. So RsNano is the Rust port of the Nano node for the Nano cryptocurrency, and yeah, I've been working on porting it to Rust for 2 years now, and oh, you updated it, LFLF, already. That's cool. Yeah, as you can see, we are making progress here, and we are actually very close to have the core of the node fully in Rust. And the stream focuses on porting it to Rust. And in the future, we'll focus on cleaning up code and writing unit tests. LFLF, so what's the name of the YouTuber you mentioned? Can you write it in chat? Yeah. You know, we could also... I'm going to stop the music for a second. And we could also just quickly look him up, because I watch his streams. Should have chat. And is it in live? Is it in videos? Giveaway time. think it's in the live videos. No? Or did it... No. Oh, maybe he streamed it on Twitch and it's now in the... on the YouTube channel from James Shore. Is it in here? Yeah. These streams, I mean, the database. Let's just check them out.
And the duck typing is...
So... yeah, so I'm not a Java developer, and I don't know if this is applicable to you, but they here in this video they are on in the whole series. So this is in the middle of the series. They are writing nullable tests for something Java based with the Java ORM stuff. Yeah, maybe this could help. I don't know. Let me know. But I'm going to write a lot of unit tests for RsNano once I'm done with the major porting work, and I'm going to use the nullable patterns there. And I'm also, yeah, generally refactoring the code to use the A-frame architecture from James Shore. You know, this very simple architecture where we just separate the code into infrastructure. Everything that talks to the outside world is infrastructure, and logic, which is all self-contained, and application, which combines both layers. Timer's not running. Did I do the giveaway? I don't remember. Did I do the giveaway? Let's check. When was the last send block created in my account? 2150. No, I didn't. I forgot to spin the wheel. Let's spin the wheel. End of null. There you go. Oh, I have to unlock again. Okay. Are you writing code on cryptography? I'm developing cryptography code in C. That's why I'm asking. But I'm writing cryptography code for authentication mechanisms, TLS, Libsodium, etc. Yeah, so I'm not... I work on cryptocurrency code, but I'm not deep into cryptography, and the cryptography that is being used in this project, I did not write it myself. I use libraries for that. Yeah, people say it's rigged. So what are you developing? Are you working on cryptography algorithms? Okay, so we are here. So we popped the front of the queue. Then we drop the mutex guard. And then we increase the node stats. Its detail type is insert manual. So this is that line. And now, then we insert it into the active transaction. So this inserts the block into the active election container. And that means we have to get the active transactions as a field. And we have to pass it into the constructor. Like that. Dilly Baltau says, no, I'm doing end-to-end implementations, and for that I'm using symmetric encryption techniques. Cool, that sounds like an interesting project. And have you worked with Rust? Okay, so we have the active elections, active transactions instance here. So we can say let result equals to self.active.insert block and election behavior. There's no insert. There's no insert. Why is there no oh, okay, I'm missing a trait in the... I have to import the missing trait here, and we have to borrow the block. Okay, so what is result? Bool and election. So this is, I think, inserted is the bool, and election is the inserted election. And now we nope, I'm warring with C actually. That what I'm wondering is Rust actively used in cryptology? I mean, is it a proven language? Because as you know, most attacks come from memory leak and side attacks. Yeah, I think that's where Rust shines. I don't know what you mean. Is it a proven language? So do you mean like is it formally proven or something? I don't think so. But the correctness guarantees of Rust and the memory safety guarantees, they are very, very helpful when it comes to safety. It's critical code. So. And it's also very performant, so I think it is a good fit for cryptography from my perspective. Okay, so the next lines are... So we're checking the election. So if there's an election, we transition it to active. So these are these three lines. We can delete them now. And now in the else block, we drop the mutex guard. Here we value moved here in previous iteration of loop. Yeah, okay, we are dropping the guard, the mutex guard, then we are calling notify, and then we are reacquiring the mutex guard. And that fixes everything now. So we are good. We are good now. No errors anymore. Let's have a look at the C++ code again. Yeah, just one last function is missing, and that is the container info. And then we can write the foreign function interface and use it from the C++ side. let's write the last one. The last function is collect container info. And this takes self and it takes a name. The name is anything that can be turned into a string. And then it returns a container info component. And so we have to lock the mutex again. And then we return container info component posit, and this is the first argument is the name. And here we have to give a vec with all the subcomponents. And there's only one subcomponent here, and that is container component leaf. That is this one. It has the name Q. The count is the guard QLen. And size of element is yeah. Oh. Size of element is... We have to compute this by ourselves, I think. So it's an arg blocking option amount, election behavior. Size of arg block enum plus size of option mount there's a syntax error here plus size of election behavior. Okay. So, first step complete. So now we ported the whole class. And the next step is to write the FFI functions. So let's let's first spin a wheel. So if you want to take part in the giveaway, just post your Nano address and you can win 1 Nano every 10 minutes. For every big Bitcoin block we send out 1 Nano. Fearlessly and instantly and eco-friendly Wendelson. Congratulations, Wendelson, for 1 Nano. Congrats, Wendelson. Okay, here we are. We have the scheduler, so now let's go to the FFI functions. Let's add a new file, manual scheduler. And here we create the handle. Oh, you can't see this. Here we create the handle. Manual scheduler handle. Will be an arc. Manuals. The manual scheduler is still not public. Manual scheduler. Roger Cruz Nanobank strong. Roger, I think. Are you in the address book? No. Okay. If you want to take part in the giveaway, just send me your Nano address in chat. Nanobank rocks, says Wenderson. Okay, so let's create the FFI functions. Rs and manual scheduler create. And it takes the stats and what else? Active transactions. And it returns a raw pointer to the manual scheduler handle. Argue manual scheduler new stats and active. Oh, not active transactions handle. Manual scheduler handle. So this FFI function creates an instance of the manual scheduler. And now let's create one that destroys the raw pointer again. Raw handle. This is unsafe. So now we have a FFI function for creating an instance. We have an FFI function for destroying the instance. Hey Roger, you sent your Nano address. Cool. Let's add you. Let's add you here. Oh, I closed mine. Let's see. Book. Save. All right. Okay, so we have one for creating the scheduler, we have one for destroying the scheduler. Now we need FFI function for all the other functions. So we need notify. Or notify. We need push. Push. And push needs log. And it needs previous balance. Oh, it's an option mount. Nah, I can make it with. I can use null pointers. Don't need an extra bool. So it will be null if it is none. We need election behavior. And it doesn't return anything. So here we say push. And it takes an arc, block. And the previous balance. So if previous balance is a null pointer, so if it is null, then we say none. Else we say sum amount from pointer. Amount from pointer. Previous balance. And election behavior. Election behavior from U8. And wrap. Good. That's the push function, and run, we don't have to write an FFI function for run because this is private. So the last one we need is no, it's not the last one. Start is still missing. Start and stop. Start and stop. Let's also add start and stop. Start calls start. Stop calls stop. Not found? Stop not found? Oh, did I forget to port the stop function? Yeah, let's just do this quickly. Yeah, I didn't port the stop function. Stop. So we have to lock the mutex and set stop to true. Then we call notify, and then we say we take the thread join handle. And we wait until the thread is joined. Like that. Okay, that was it. Okay, that was the stop function, the notify, and the push. The run, we don't need that. We need the collect container info. And I'm just going to copy the collect container info from another class, because it's always the same. So let's just copy that. And let's just rename this to manual scheduler collect container info. Alright, let's import all the missing imports. What's wrong here? Oh, C string is still missing. C string. And that's it. That's 0. That collect container. Now, no handle. That's it, guys. That's it. We have the class ported. We have written the FFI functions. And RsNano gets a nano. So all is looking good. So we have still plenty of time. to now use this. Sorry guys, says Andifnol. Roger says, what is the manual scheduler supposed to do? Locally publish blocks? Yeah, so I don't know this code like really well, but a quick look at the beginning of the stream, I saw that it is used a lot in the tests, and it is being used in the RPC. So there's confirm block RPC, and that pushes the block into the manual scheduler. Yeah, it's forcing elections, yeah. So now we can now use our new FFI functions in the C++ code. And that will be easy. So first we need constructor. We need a constructor, a destructor. Oh. And we have to forbid copying here, because these handles are not copyable, these Rust handles. So let's add our Rust handle at the bottom. Manual scheduler handle. And now oh, there was a constructor already. Oh, they are down here. Okay, we don't need them. But we still need to forbid the copying. Okay, so... and... okay, so this is... this is all private. That means we don't even need FFI functions for notify. Let's remove that. Okay, so let's remove all of the private stuff. And now let's go to the constructor and let's initialize our handle with the corresponding FFI function. And it takes nodes, that's handle, and node active handle. And the destructor calls the destructor FFI function. Manual destroy. The start calls manual scheduler start. The stop calls stop. Notify, we don't need that. Push. Push has to call manual scheduler push. And this takes the block. And it takes the previous balance as a pointer. So this means let's just initialize it to null. Does this work with auto? Do I have to give the type? It's a byte pointer. And if previous balance has a value, then I can say previous pointer is previous balance value What does value return? A reference. Bytes data? Oh no, it is. What is previous balance? What's the data type? uint 128T. So we have to convert it into a nano amount. Like that, and then we can assign the pointer to amount bytes data. Oh, this is ugly. So previous pointer, and the last one is the election behavior, and we have to cast election behavior into a byte. I think this should work. Roger asks, can I copy your Vim config? Sure you can, because I copied it too. Oh, but it's not, want to see it, it's just simple. I copied it from, oh, what's this famous Rust streamer's name? Oh, it's late. Predicate, so we don't need predicate. The last part is collect container info. And here again, I'm just going to copy it from another class where it is ported already, and it's always the same code. So just pasting it here. But we have to call not TCP channels collect container info, we have to call manual schedule collect container info. And now that's it. We are done. We are, yeah, John Who, yeah, that's the one I'm, John Jenks it, that's the one I mean. He has a public GitHub, a repository with his configuration, and I copied a lot from him. Do you mean code to the moon? What is code to the moon? We're done, guys. Just look at the manual scheduler. It shrank down. And now it's time to compile everything. Or let's reformat the code first. Let's reformat the code. Let's compile everything. Let's run the tests. Let's give away the last nanos. And let's call it a day. So reformat it. Let's build everything. And let's run the tests. Oh, Code to the Moon is another Rust YouTuber. Good to know. Yeah, I'm really happy with my NeoVimsa setup. So, Bitcoin block time. Almost there. Let's spin it now. Congratulations. How do you pronounce your name? Is it Jabba? Is it Yubu? Is it Jubu? One nano for you. There you go. And how many nanos do we have left now? Two nanos left. Yeah, still building. And yeah, as you see, it's not hard anymore to port the remaining things. So this is now the manual scheduler, so just hinted and the optimistic missing. And then we have all these schedulers ported. And yeah, the Rust node is coming closer. And also, once the core team releases a new C++, the new v27 version, I think I want to release an alpha version of Rust, of the current state of the Rust code too. With the big warning, of course, that this is untested and dangerous. But maybe people want to try it out and give me some feedback. On my new computer, this would be done or finished long ago. RsNano launch party, yeah. Yeah, that's a good idea, a launch party. Then let's make like a super long stream where we all party. And then not with elevator music, and with party music. Compiling. Yeah, it makes such a difference if you don't have to wait anymore. So my workday now in the office, it is, I'm so happy. Like I make many changes and then I just recompile everything and boom, it's done. Maybe we can ask Gravity to stress test in the testnet. Oh, he does from time to time actually. So he tested RsNano multiple times in the past and it performs pretty equal to the C++ node, even though there's a lot of glue code going on. Nefnal says, damn, I'm hungry. I'm going to have my own private lunch party in the fridge. So, almost there. And then, once we have it in Rust, then the real work can begin, because people think yeah, porting this stuff to Rust and then I'm done, but porting it to Rust is just the very first step before the real work can begin. And the real work is cleaning everything up and refactoring everything and making the unit tests really fast with nullables and yeah, getting rid of all of the circular references and stuff. So there will be a lot of work to do, and async, optimizing the async code. So there will be a lot of interesting work to do once everything is in Rust. %. Oh, takes too long. It just takes too long. Now I'm spoiled. I'm spoiled with my computer from the office. And of course, the question is, will it run? LFLF says, when everything is in Rust, can you give a higher level technical overview over the whole Nano node? I would love to help out again with development. I will. And the reason why I haven't done anything like that is because I myself don't have a high level overview of everything. So let's run the tests. But I will. I will. I definitely will. Yeah, it's looking good. It's looking really good. So we did it. NanoFam, we did it. We ported the manual scheduler. LFLF, do you still have these tests that fail, sometimes fail randomly, or were you able to fix those issues? I fixed most of them, but there's still some tests that sometimes fail. But it's a lot better now. This is that stuff, the FFI, a Rust implementation, okay. Port manual scheduler. Let's push it. Push it good. Roger says, we have lots of devs. This is a good sign for the community's health. Yeah, and there's lots. Let's just go to this wonderful site, nano.casa, where we can just see the development activity. And yeah, if you look at that graph, there's a lot of development going on in the last months. And as you can see, a lot of development going on in Nano, in RsNano. Yeah, that's good to see. And here we are. This was us. No, remove C++ buckets. Yeah, that was the commit at the start of the stream. So things are looking good. Yeah, and I have to spend some time porting the upstream commits again. Merging them. Merging those upstream commits is such a painful task. 43 already. But I think I will do this this week. And I won't focus on porting so much. And just I want to catch up again with upstream. Yeah, but that's it. That's things are looking good. And also, so the testability is also now visible. It's failing here in the GitHub Actions. And 3 red tests in a row. Yeah, as you can see, we have green builds. More and more green builds here, and they used to be a red all of the time. Oh. Maybe what's going on here? Oh, the Rust tests are failing. I think I checked something without... I didn't run the Rust tests. Let's run the Rust tests. And giveaway time. Okay, there's one test that is failing. Oh, I know why. I refactored the helper function before the stream. I refactored a helper function that is used in the tests, and I think that broke a test. State blocker is for 19. Oh, come on, let's just fix it quickly. State block. Okay. Yeah, I refactored the create test instance function to use a different private key. So I think the fix is just to copy the new output and to replace the expectation with the new one. Or maybe what changed? Maybe just the account? I'm not going to do this now. Let's just give away the last nanos. Albert Taihon, are you there? Yeah, I'm there. I'm there. So Pice wins 1 nano. And let's give away the last nano too, and then let's end the stream. So the last nano of the stream. You ready, guys? Let's go. Oh, is it? And if null again. The game is rigged. How do you do it? How are you rigging the game, man? And if null gets the last nano. So, thanks for watching, guys. Join the RsNano Discord if you want to chat about RsNano or if you want to help with the project. So you can find the link here on rsnano.com. I will try to stream regularly again. No promises, but I will try. So next stream will probably be next Tuesday, same time and same place. Have a great week, everyone. And Nano is the light, as Wenderson always says. Alright, guys, bye. It was fun.